Hello, everyone, and welcome to the United Nations University Institute for Water, Environment, and Health Science Talk series as we celebrate our 30th anniversary year. My name is UNU-INWEH, UNU-INWEH's Public Outreach and Education Associate, and I am delighted to be your host today for the Science Talk. For those of you who are joining us for the first time, our Science Talks showcase the diverse policy relevant and interdisciplinary research of UNU-INWEH and our global network of experts. These sessions are designed not only to share cutting-edge science, but also to explore how that science translates into real-world solutions for water, environment, and health challenges around the globe. Today's session, like all of our talks, is being recorded. The video will be made available in an open access format following the event. And you can find recordings of all previous science talks on demand via our website and YouTube channel at unu.edu/inweh/science-talk-. We're also pleased to introduce the YouTube live streaming option, which makes it easier for everyone to join our science talks. There is no need to register to watch live. Simply go to the UNU-INWEH YouTube channel and click on our profile pic to access the stream. As always, we will conclude with an interactive Q&A session. Please feel free to post your questions in the chat at any point during the presentation, and we will address as many as possible towards the end of today's session. Today's science talk is entitled Water Security Under Pressure, Navigating Water Challenges and Strategies Across the Gulf Cooperation Council. And it is my great pleasure to introduce today's speaker, Dr. Mohammed Mahmoud. Dr. Mohammed Mahmoud leads for Middle East Climate and Water Policy at UNU-INWEH, explores the complex and evolving water security landscape across the Gulf Cooperation Council. Against the backdrop of arid climates, rapid population growth, and intensifying climate pressures, Dr. Mahmoud delves into the challenges facing conventional water resources and highlights innovative pathways being pursued across Bahrain, Kuwait, Oman, Qatar, Saudi Arabia, and the UAE. From expanding desalination capacity and advancing wastewater reuse to deploying emerging water technologies and strengthening integrated water management approaches, the talk shed light on how GCC, Gulf Cooperation Council countries are building resilience against growing risks, including sea level rise, extreme weather events, and groundwater contamination. By examining both regional shared priorities and country-specific strategies, this session highlights the critical role of resilient infrastructure, innovation, and regional collaboration in securing sustainable water futures in an increasingly uncertain world. Please join me in welcoming Dr. Mahmoud for today's science talk. The floor is yours. Please go ahead, Mohammed.
Thank you for the kind introduction and a warm welcome to all viewing, and a very early good morning to you all from Phoenix, Arizona. As was mentioned, a very nice introduction. I am the lead for Middle East Climate Water Policy at UNU-INWEH, and the presentation I'm sharing today is looking at water security issues in the countries of the Gulf, specifically those that are collectively called the Gulf Cooperation Council. What I'm presenting today is essentially a highlight of research that I had completed and concluded earlier this year and was published. I'll provide the link to that article at the end of the presentation for those that want to take a deeper dive on the policy research and analysis conducted. But this is really to give you a flavor of some of those issues that those countries collectively share, as well as prominently address individually. That is, from my assessment, the highest of their concerns. So I guess maybe a good place to start, just in case to set the baseline, what is the GCC? We refer to a GCC in abbreviation, but this is essentially the Gulf Cooperation Council, and it's a collection of 6 countries that have come together sort of economically and socioeconomically and geography-wise as a collective. And this includes Saudi Arabia, Kuwait, Bahrain, Qatar, the United Arab Emirates, and Oman. And so they're primarily situated on the Arabian Peninsula. So this is the GCC. One of the interesting aspects or realities that the GCC faces, especially as you look at their location within the Arabian Peninsula, it is a very arid and dry part of the world, specifically within the Middle East context. One way to really frame that is to share with you a metric, which I'm sure many are familiar with, is this idea of water stress as defined by the UN Sustainable Development Goal 6 within 6.4.2. What I'm sharing with you here in the table is essentially the level of water stress that each of those GCC countries face. And water stress, just to be clear, for those that may not know exactly how that is defined, in this particular context, we're referring to water stress as basically the ratio of total water use, or withdrawals to be more technical, as compared to total available freshwater resources. So essentially, how much of their use comes from available freshwater resources. And what you'll see right away is that number for all of those countries exceeds 100%, and some far larger than 100%. And the reason why that is this is basically an indication of how limited freshwater resources are in the region. I mean, look at these figures. As I said, over 100 at the low end, you have Oman at 117, Bahrain at 134%, and then it shoots all the way up as high as 3,851% Kuwait, and on the order of 1,500% for UAE. So what does that really mean? Well, as I hinted, it indicates that these countries have very limited freshwater supplies. In fact, these countries essentially don't have surface water systems to speak of. Maybe in the case of Oman, there are intermittent rivers and streams that occur. But essentially, there's no robust surface water systems that can be reliably depended on to provide a water supply for these countries. So when it comes to fresh water, these countries really have only one option, and that is groundwater. And groundwater has been quite a robust resource for this region for decades. However, centuries, I should say. However, that is a finite supply that is largely non-renewable. So the question becomes, where does this extra supply come from to meet all the water needs of this region? This is just an image credited to Al Jazeera, specifically sourced from the GCC Statistical Center. And it just shows you the reliance of these countries both on groundwater as the freshwater source that is exclusive, that is only available to them, and what is primarily used to bridge that gap between supply and demand, and that is essentially desalination. Desalination is the lifeline of this region. Without it, much of the socioeconomic growth and water use could not be achievable or fulfilled. There is some small amount of treated wastewater that exists in some of these countries, but as of today, not really a large component of their water supply portfolio. But the message I really want to convey here is that groundwater is their primary freshwater supply, which shows you why they're in such deep water stress. And then desalination is their primary non-conventional water supply that really makes this region viable to survive, frankly. And although desalination is a huge component, production capacity varies, and there's a number of reasons for that. One is the need for the supply based on the level of demand. And so you can see here this graph is indicating from 2013 to 2022 the amount of desalinated water produced in million cubic meters per year, clearly, there's quite a demarcation between Saudi Arabia and United Arab Emirates. It's where a lot of intensity in terms of either population or use, and we'll talk a little bit more about those examples in the following slides. And then the others are a little bit lower in the graph in terms of their desalinated water produced. But that doesn't really, don't take that as an indication that it's insignificant. I mean, this is quite still a significant amount of desalinated water produced to be used in proportion to those countries. Certainly, when you look at Qatar, Kuwait, Bahrain, to a certain extent, Oman, although Oman is geographically a larger country, but all these countries at sort of the lower end of this graph aren't necessarily as population intensive or use intensive as Saudi Arabia and United Arab Emirates when it comes to water. One of the interesting questions that always pop up when we talk about desalination within the GCC countries, and primarily a lot of these desalination plants are in the Gulf. Certainly in the case of Saudi Arabia, they do have desalination plants on the Red Sea. But there's this concentration of desalination plants in the Gulf, not only in the GCC. Certainly, when you look across the Gulf, Iran has certainly desalination plants that tap into that water resource, or that water body, I should say. A little bit up the Gulf, Iraq has potential there as well. This question pops up a lot, and what is really the impact of all of this desalination on the salinity of the Gulf as a water body? Conventional thought or perspective, and the reason why this is a question is from an environmental concern perspective. Folks always ask the question is, what is the effect of all that brine in terms of the environmental quality of the Gulf itself? How does it affect water quality? Increased salinity isn't necessarily a good thing. How does it affect marine life, certain marine species and fish species that this region relies on in terms of aquaculture and food supply could be negatively affected by salinity. So it comes from an area of environmental concern. There are some interesting findings that I came across when doing this research, and certainly even prior to this paper. A few things became quite apparent, and this is what the research indicates to date. Obviously, and I think this makes intuitive sense, is that you do indeed see an increase in salinity in brine, which is the discharge from the desalination process, near the areas where those desal plants exist, right? So as they're taking in water, undergoing the desal treatment, that brine is discharged close to that extraction point. And so you see an increase in salinity when you take sort of a point measurement of water quality there. The other thing that occurs is these salts or brine or added salt salinity that is introduced to the Gulf. Most of it actually starts to sink and accumulate near the bottom of the seabed of the Gulf itself. So that's just the point I want you to hold on to for a moment, because it's going to take us to the next findings and conclusions from the research that I think will surprise a lot of people, and certainly surprise myself and fellow researchers looking at this topic, which is, strangely enough, and maybe not so strangely once I explain why, the basin-wide impact to the Gulf from all of this desalination activity is quite minimal. There's really, when you look at it as an entire water body and sort of take the monitoring data in terms and measurements in terms of overall salinity, there's really very little change to the salinity of the Gulf. Again, basin-wide or water body-wide from the point of the inlet inwards. And in fact, the research essentially compares it to seasonal fluctuations in salinity. That's how small this added desalination brine salinity does to the Gulf. There's a couple of reasons for that. One reason, but two mechanisms, which is the water within the Gulf itself is not static, If it was, that could be a different story. But it's not a lake. It's not a pond. It is a gulf that is connected to the wider Arabian Sea and then the Indian Ocean. And so water exchange through the inlet of the Gulf, essentially the Strait of Hormuz, continuously flushes out this this potentially high saline water from desalination out of the Gulf, and then through this mixing of water exchange in and out, less saline water comes in from the larger water body it's connected to, which is the Indian Ocean. And so this occurs over its sort of deep water currents and then surface water sort of circulation due to the movement of winds. And so this mixing and circulation essentially helps the Gulf from continuing to increase its salinity, as you might think, because of these, this high activity of desalination, the larger number of desalination plants lining the boundaries of the water body of the Gulf. One question, the point of this is not an immediate concern, but there is a legitimate question to ask that, decades and hundreds of years into the future, is this still a point of concern? And frankly, that's a valid question. But to date, since essentially the 60s and 70s, when desalination has really come online in this region, to date, so we're looking at least about 50 years, the impact has really been minimal. So in looking at this analysis, really, in terms of the water security for the GCC, I looked at several dimensions of water management, primarily initially starting with water supply. And the case study there I'll present the highlight of looks at water systems redundancy associated with water supply, and this is the case study for Qatar. Water quality dimension, and here looking at groundwater pollution, the case study of Kuwait. Water demand as the third dimension, and looking at issues of scale versus intensity when it comes to water demand. Water use at scale for the case study of Saudi Arabia, and then water use intensity based on types of demand from the UAE. And then finally, water infrastructure, the dimension of water management related to water infrastructure, with a couple of case studies, both connected to climate change. First, the case of Oman, looking at extreme weather and how that affects water infrastructure, and then sea level rise in Bahrain as the other case study connected to water infrastructure. So in the case of Qatar, really the primary concern, again, from my assessment and this research analysis, is this attempt to achieve water resources diversification. And this is relevant to Qatar because of a couple of very apparent points. Its extreme dependence on desalination. Desalination supplies 60% of Qatar's water use entirely. You may recall the earlier graphic that I showed talking about the sources of supply for this subset of countries, groundwater and desalination. And desalination arranged, as the entire water supply is, I think, number as low as 30%, going up to a little bit higher than 50%. However, when you parse that out to drinking water, for many of those countries, desal then becomes really the lion's share of that water supply. The example of Kuwait, 90% of desalination satisfies drinking water. But even for Qatar, just overall, desalination supplies 60%. So that's quite high in contrast. Coupled with that, as we mentioned, the reliance on groundwater in the region, Qatar has significantly relied on groundwater, which has led to overpumping. There's very little recharge. Again, this is a very arid region, not a lot of rainfall. So there's a natural aridity and drought conditions that exist. And because of this overpumping, and Qatar is essentially a peninsula on a peninsula. The country of Qatar appears as a peninsula attached to the Arabian Peninsula. That pumping has led to seawater intrusion, surrounded by water essentially on most sides. And then now the groundwater resource, unfortunately, in areas where the seawater intrusion has led to the need to this water also undergoing some level of desalination process, which is an added burden of treatment that otherwise, if it was still a freshwater resource, it wouldn't have to go all the way through. One of the interesting cases with Qatar that I think has really led to its sort of evolution in terms of water management is back in 2017, where the country underwent a political blockade from its actual GCC allies. And that constrained the movement of things, everything really, into the country. People, flights to surrounding GCC countries were suspended. Trade routes to those countries were also suspended. We'll talk about Saudi Arabia in a minute, but Saudi Arabia is a huge food provider to the region surrounding the GCC, but to within the GCC as well. So that was a huge crippling vulnerability to Qatar because of that being a large component of its food supply. And so uh, once sort of the political rift was eased and healed, and Qatar was moved forward in well with its GCC allies, um, things resumed to normal. But there was a hard lesson learned here, which is the vulnerability of really relying on external networks to satisfy domestic needs. And so Qatar shifted towards looking at ways to diversify its production capacity, both in terms of water and food, and to reduce its reliance on some of these external supplies and imports as a way to increase its own resilience. This manifests in a couple of ways. We'll talk about the food angle, and we think of food as sort of a virtual water component in this regard, and certainly Qatar did as well, which is it developed shortly thereafter from the start of the blockade, its national food security strategy, which looked at ways to diversify trade routes, ability to import food, domestic food production, and really buffer its strategic food reserves to avoid this issue of extreme reliance. Consequently, over that period from 2017 to 2023, its self-sufficiency when it came to vegetables, as an example, increased from 10% to 46%. I mean, part of that was a necessity because of the blockade itself, but I think it laid the groundwork to expand its self-sufficiency in a way to minimize any future disruptions of any kind that limit its ability to rely on external food and water virtual imports. Uh, One of those is obviously the reliance on food, and so it shifted its agricultural demand in terms of reduction. There's been an increase in referred to as hydroponic farming, which is indoor greenhouses type farming. That addresses the issue of limited arable land. Qatar isn't necessarily a large country, and so there's certainly limited areas of arable land to grow crops. But hydroponics circumvents this issue. Bahrain has also done a similar thing as well. Bahrain is the smallest of the GCC countries. It's a very tiny island, series of islands. And in this case, by going through the hydroponic farming process, there's a potential of reduction of freshwater use by 70% in comparison to traditional farming techniques, open field agriculture. In terms of the water side, huge investments in water infrastructure to create a water redundancy system. Investments of over $22 billion in water infrastructure aspects of drainage, flood prevention, pumping and water pumping and water treatment, and expanding networks, conveyance systems, and pipelines within Qatar, again, to build their resilience. And expanding really their strategic water reserves. One way of doing that is through their strategic outfalls project, which takes advantage of collected or harvested rainwater and wastewater reuse, essentially for the purpose of irrigation and cooling from the energy and power plant perspective. So that helps to support reductions in water loss as well as per capita consumption, which, as you can imagine, can be quite significant for a country that has limited freshwater resources. Shifting to Kuwait, the concern there really, I think, a topic of concern that this analysis focused on is how groundwater contamination has affected their water reliability. This is unfortunately a legacy from the first Gulf War from the late 80s, 1989, 1990, where after Iraq had invaded Kuwait for a period of months, as the liberation of Kuwait was underway through Allied forces, the Iraqi army, as they were retreating, set fire to hundreds of oil wells that created hundreds of oil lakes that then created these ponds and pools of hydrocarbons and heavy metals and toxic byproducts and crude oil that essentially contaminated the soil. And with time started to infiltrate deeper into the soil, now contaminating the groundwater underneath. An unfortunate side effect of the needed sort of expediency to address putting out these fires was using seawater to extinguish the fires and flames. So you can imagine that seawater is highly saline. That also introduced a salinity element to the groundwater as well. And so with time, and this is we're talking about an order of 40 years or so, when rainfall events occur, that helps to carry the contamination even deeper into the soil and deeper into the groundwater aquifer. And monitoring studies have confirmed the high level of groundwater contamination from these petroleum hydrocarbons and dissolved solids from all of these oil lakes and spills that have occurred on land because of the fires and putting out of these fires. Groundwater, despite all that, groundwater is a huge component of Kuwait's water supply portfolio. About half of groundwater that's available to them, that isn't necessarily contaminated, is used for agriculture and also supplies over 90% of both residential and industrial water needs. So 90% of industrial water needs is satisfied from groundwater, and 75,000 users or customers in Kuwait rely on groundwater. And frankly, for them, it's water that is available at a lower cost than obviously desalination and water recycling, both intensive treatment operations that also have high energy components. Certainly, desalination does. But Kuwait hasn't been static for 40 years on this issue. The Kuwait Environmental Remediation Program that was kickstarted in 2012 provided a framework for identifying, excavating, essentially removing, treating, and safely disposing of the contaminated soils under the oversight of the Kuwait Oil Company. But it's a huge effort that's obviously taken decades and continues to be just because of how long the contamination has been there and how much it has spread during that time, again, both in the soil and the groundwater. So a key component that I think underlines Kuwait's urgency to increase its water security and water reliability is looking at the restoration of both the soils and the groundwater quality, so it can be an even more viable source of water, reducing demand essentially on the highly intensive and highly costly desalination. Another aspect or point it raises is the importance of regional cooperation, simply because managing groundwater sustainability requires looking at groundwater aquifers as a shared resource, which it is. It doesn't follow surface boundaries and transboundaries, but it is shared by several countries, including their GCC neighbors. And so when an aquifer is impacted, like in this case of contamination or increased salinity, that affects all users. And so there's an impetus to collaborate on such issues. We'll shift to water demand here after talking about water quality with Kuwait and water supply issues in Qatar. And drivers of water demand, really, I like to think of it in three big buckets. Agricultural water use, which is the largest component of water use worldwide, and certainly is in the case in the larger region here. 70% of water use worldwide is accounted for agriculture and food production. Then you have residential water use. This is what I classify as essentially municipal, domestic water use for homes, sanitation, drinking water, essentially for human consumption and needs. And then industrial water use, which is actually a bigger category than the name implies. Industrial, certainly in the sense of water used to help manufacturing and production of goods and that type of thing. But in this region, it actually takes on a much more significant role when we think of the energy generation capacity of this region, fossil fuel industries and natural oil and gas. Uh, all of those require power plants that generate those fuels, if you will, into electricity. And power plants of all kinds essentially require water for cooling purposes. And so water is an important component of the energy generation uh, chain for these countries. And the issue, I think, when we come to water demand, and you'll see in the contrast of these two examples I'm going to share or case studies, is water demand in terms of scale, how large the water demand is to satisfy maybe scale in terms of geography and needs, but also water intensity in the sense of different types of water demand driving the overall water use component. So we'll look at Saudi Arabia first, and this is really the case of water use at scale. And Saudi Arabia is a very large country. It certainly takes almost the entirety of the Arabian Peninsula, with the exception of Yemen and Oman at the bottom end, and has a vast geography. And so this scale in terms of land size, it's the largest of the GCC countries, uh, poses an interesting challenge when we think about water distribution to satisfy water demand across the country. So that's a very important challenge to consider. Certainly, there's a couple of major cities within Riyadh, which is more inland in the east, and Jeddah, which is on the coast in the Red Sea. But there are also many communities and towns and cities within that also need to have reliable water supplies. Saudi Arabia, as I mentioned, is the larger and also in terms of scale, but also in terms of population. 60% of the GCC's population lives in Saudi Arabia. So over half of the GCC population is within Saudi Arabia, which makes sense considering its size. And consequently, it is the world, not just the region, but the world's third highest per capita water consumer. So you're dealing with issues of geography as well as demand. So this is the point of scale that I was trying to illustrate. Another aspect, and you'll see in the first image there, Saudi Arabia has invested immensely into mega infrastructure projects. This is an old country in terms of culture and history, but still very much in the swing of urban development and huge infrastructure projects. I'm sure many of you have heard of NEOM and the line in Western Saudi Arabia, this future sustainable city that has been in development for many years. Of course, if you're going to build huge infrastructure projects to support large urban areas and consequently populations and other residential infrastructure, you need water supply and significant amounts of water supply for the construction aspect as well as the operation of those new areas. The other interesting thing in Saudi Arabia is actually, and I hinted about it earlier when I talked about Qatar's previous reliance on its food systems. Uh, Agriculture is really leads water use in Saudi Arabia because it is a huge supplier of food and food products around the region, around the GCC and outside of the GCC. In the case of Saudi Arabia, agriculture consumes more water than their residential and industrial sectors combined. So that gives you a sense of how large that is. And when you look at the industrial and residential uses, um, even though they're smaller in terms of water footprint, when it comes to expenditures, water-related expenditures or expenses, they account for about 61% of that. So more of the cost related with water comes from the residential and industrial side. That kind of makes sense when you think about the intensity of those sectors. Certainly, if you roll in energy production, desalination, as sort of an industry water-related expense in terms of construction and energy and so forth. So the high cost of water treatment as well as distribution falls on the residential and industrial side. So the costs there are expectedly higher. Consequently, Saudi Arabia has really doubled down on water security as its sort of future strategy goals. And this is really encapsulated in its highly touted Vision 2030 plan. And looking at things at improving water efficiency by reducing water losses both in the agricultural and residential sector, looking at ways to enhance irrigation using updated irrigation or new irrigation methods, improving water recycling or wastewater treatment and water reuse, and looking at renewable energy, increasing renewable energy as a source of the energy that desalination relies on. You may have seen in recent news that Saudi Arabia has proclaimed 2027 next year as the year of water. And next year as well, the World Water Council is hosting their conference in Saudi Arabia as well. On the flip side of scale versus intensity, when we look at intensity, the UAE presents an interesting case of huge socioeconomic growth that really is quietly underpinned by water. UAE is fast becoming a global hub for finance, tourism, and innovation, with a population growth increase of 30% over the last 10 years. And a lot of it's driven by international residents. A lot of expats come to live in, very popular city of Dubai, as well as other areas like other major cities like Abu Dhabi and Sharjah. And so you have a huge influx that really impacts the need for residential water supply. Obviously, this growth becomes water intensive. When you think about urbanization, tourism, real estate development, there's huge real estate development to account for this increase in population. So municipal or residential water supplies or water use becomes inflated as a consequence. Much like the rest of the GCC, non-conventional water becomes central, of which the most of comes from desalination and treated wastewater. That is a component here. And 73% of treated wastewater actually is used to irrigate public green spaces within these residential areas. Water security is a huge strategy of UAE as well. In the Water Security Strategy of 2036, the targets for UAE is to look at a 21% reduction in overall water demand. So that's looking at ways likely to improve efficiency, as well as increasing wastewater reuse by 2036 as well. So to boost that component in their water supply portfolio. It will never be a huge component of the water supply portfolio, but to boost its amount still will help to reduce reliance on desalination and groundwater. And the UAE continues to provide investments and innovation through a number of channels that look at sponsoring funding opportunities, awards, research prizes, etc., that look at partnerships, research, innovative solutions that help address water scarcity in arid environments, which obviously includes the GCC and the UAE. So as a benefit to the UAE, but to other similar regions across the world. So this huge boom of socioeconomic growth is really going to stress the water supplies that the UAE currently has. And so it's really looking at addressing this intensity in water use by looking at ways to improve its water reliability. Looking at the last water dimension component of critical water infrastructure, when we think about that, just to be more clear, obviously we're looking at things like desalination, groundwater pumping, water treatment, delivery networks, pipelines, water storage facilities that are critical aspects of water infrastructure or robust water infrastructure, really anywhere, but certainly in the case of the GCC. But these have been really impacted by a number of things, but the one I'll focus on here, which is relevant to the two examples, is climate change. Specifically extreme heat, which increases the wear and tear and reduces the lifespan of these assets. Extreme weather, which could cause potential damage at very sort of fast and short durations. And then in the longer term duration, the impact of sea level rise to this infrastructure, especially if they're coastal, which is, in the case of GCC, most of their major cities are indeed coastal along the Gulf or the Red Sea. Or in the case of Oman, actually, the Arabian Sea as well. We learned this year And again, I concluded this research right at the beginning of this year, around the January timeframe. We learned that there is another threat to critical water infrastructure, obviously besides climate change, that I don't think many of us really considered because it didn't seem to be uh, 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 a manifestable threat or viable threat, which is unfortunately because of the conflict that's happening in the Gulf in terms of the attack on water infrastructure and specifically water desalination plants. And if you've been following the news for the last few months, this has made its news cycle around the world, certainly in March when the first attack happened, first attacks, I should say, on several countries' desalination plants, and have sporadically continued since then. So this was not addressed in the study, as I mentioned, was concluded before the current conflict has occurred and how it has manifested to impacts to water infrastructure, but just something to consider as well now moving forward that will certainly be a consideration in terms of these countries' protection of their water supply. So first, we'll look at Oman and their case study, looking at how extreme weather and flooding has impacted their water infrastructure. Oman is unfortunately on the front line of extreme weather in this case. It has extensive coastline along the Arabian Sea as an extension of the Indian Ocean. And because of warming that has occurred, or certainly increase in sea surface temperatures, has generated a lot of extremely severe cyclones in the Arabian Sea. There's been an increase of 150% since 1982. And when you have that generating in the Arabian Sea, your first sort of target or first in line, unfortunately, due to geography, is Oman. And so it's exposed to a lot of these cyclones or extreme severe cyclones and extreme thunderstorms making landfall in Oman. And so they're vulnerable to these cyclones and storm surges and flash flooding. Obviously, you see these images to your right, those are both from Cyclone Shaheen in 2021. The type of flooding that comes from these cyclones is really devastating in terms of damaging water infrastructure, storage dams or reservoirs, water treatment, desalination plants, distribution networks, pipelines, all underwater. So you have that impact to the physical infrastructure as well as your groundwater. I mean, look, when there's pooling of this magnitude and you have debris and contaminants, at some point, all of that ultimately infiltrates into the soil, affecting the groundwater aquifers. There is also huge socioeconomic impacts beyond infrastructure. Take the example of Cyclone Gonu, which was, I believe, in 2007, was the most intense cyclone to make landfall in Oman, causing over $4 billion in damages and around 50 deaths, fatalities that have occurred. It's important to not forget the human cost as well. But again, Oman, like its neighbors, haven't sat idly in the face of the challenges that they endure. And this is really an existential threat for Oman. Some of the other countries in GCC do experience some of this extreme weather, but they're either more inland or up the coast, so to speak. So some of the impacts are slightly diminished, not always, such as the case of the 2024 intense rainfalls in the UAE, which also affected Oman first. But Oman has looked at investments to improve, I should say, their flood protection and water infrastructure. So they've looked at $630 million in loans to achieve that. And an extension of that, improving their flood preparedness, because that is really the risk for them and for the water infrastructure. So updating their flood risk plans and integrating flood risk into urban planning. And the reason couldn't be more dire. So Muscat, the capital city, projections have indicated that, or analysis, I should say, have indicated that half the city is exposed to flash flooding from these storms. And just in terms of sea level rise, about a fifth of the city is vulnerable to coastal flooding, both in terms of sea level rise or from these storms as well. And our final case study in Bahrain is looking at the sea level rise issue. Bahrain is a very small island, smallest of the GCC, surrounded by water on all sides. This is the image you see here. It's the main island with a series of smaller connected islands. It's flat, and because it's small, there's high population density. And a lot of its development is along the coast, again, making it vulnerable to coastal flooding. Rising seas, so rising sea level rise or sea level rise, causes the potential of saltwater intrusion, much like the case we talked about with Qatar, which is also smaller but a peninsula, small country but a peninsula, affecting the freshwater viability of the groundwater. So again, degrading groundwater quality. And a lot of the water infrastructure is coastal by nature of it being an island, but just in terms of placement a slow sea level rise, even though it takes order of magnitudes of years, could inundate these water treatment facilities, and then you have an issue of disrupting water service. Data has indicated and quantified this impact. So sea level rise has been increasing on a magnitude or order of 1.6 to 3.4 millimeters per year since 1976. And projections show that a 2-meter rise could inundate 18% of the country, while a 5-meter rise would essentially inundate almost all of Bahrain, essentially wiping out this island nation. So this is a very, very serious issue. One of the strategies that has occurred regardless of sea level rise, but more of an issue of the limited land available to Bahrain, but serves as an adaptation to sea level rise is land reclamation. Bahrain has been extensively extending its land mass and essentially its coastlines further away from its existing population density. But there is concern that even with this reclaimed land, that sea level rise could continue to inundate simply because reclaimed land can still become vulnerable if also densely developed. And so there's a need to create these coastal buffers and floodplains into these reclaimed areas so that you don't essentially just extend the same issue into these new reclaimed lands. So I'll summarize here in my last slide, really what I think are cross-cutting challenges and strategies for the GCC countries based on this analysis. On the challenge side, it's really critical that there is a need to build resilient and reliable water systems because there are vulnerabilities in terms of redundancy, reduced redundancy, and adaptable infrastructure. So there's an important need or challenge of building these water systems to really be able to adapt to a number of issues. I think it's also become clear that water scarcity, though a driver of the conditions in the GCC, shouldn't be the sole focus when it comes to water management and water reliability and water security. Incorporating climate risks, population growth, socioeconomic growth, and the increase in water demand are just as equally important. And then there is a challenge of managing environmental and climate risks. We talked about extreme weather. We talked about sea level rise, flooding, as well as degradation of freshwater supplies. These are quite important to maintain robust water supplies. And then overcome regional coordination challenges. We talked about the blockade being a blip, unfortunately, in the past, but then also regional water challenges when we talk about aquifers, but also in terms of just larger water security. There's opportunities to pool efforts together. And then ultimately, the reality is there is limited water supply, even when you factor in non-conventional sources. So there is the need to balance the development goals of these countries with the available water supply and the water security challenges that they face. In terms of strategies that we've outlined or that I've outlined in this analysis, that correlates to some of these challenges, the need to strengthen water resilient infrastructure, investments, expansions, redundancies, so that under extreme scenarios, both because of climate or water demand or geopolitics, these countries can still weather that storm, so to speak. Expanding water resource management or integrated water resource management. So connectivity between your supply and demand in terms of sensitivity and the feedback loops is quite important. Climate adaptive planning is necessary. So looking at water water security from a climate risk lens is also quite important, as we've mentioned in the last few examples, and the need to accelerate innovation and efficiency. Water efficiency can help address some of the water gaps imbalance that supply may not be able to. And then we've talked about strengthening the regional cooperation in terms of shared aquifers, water quality, emergency preparedness, and again, aligning water security with long-term development goals. That's the conclusion of my talk. This is links to the paper that has a deeper dive on all these topics, and just want to give a credit to the Anwar Gargash Diplomatic Academy Center for Climate Diplomacy that supported this work. And with that, I'm happy to take any questions.
Thank you so much, Dr. Mahmoud, for such an insightful presentation. You've taken us across all 6 GCC countries and shown us that water security is not simply a question of physical scarcity, but also shaped much by how water is supplied, how demand is managed, and how water quality is protected, and how infrastructure responds to growing environmental and climate pressures. I'd like to begin with some broader regional perspective questions. If you had to identify the single greatest pressure on water security across the GCC today, what would it be? And do you think the region is currently adapting quickly enough to that challenge?
Yeah, that's a good question. My answer is going to sound counterintuitive to one of the last points I made, but you've asked me to name one thing, but I think all those other things I talked about connect to that, which is I think essentially water scarcity, drought. The aridity of the region is its most premier challenge. The fact that there's limited rainfall. In fact, in some cases, it's a deficit when you look at rainfall and evapotranspiration or evaporation in the region. And then the limitation in terms of non-renewable water supplies. There really is no robust surface water systems. That is the challenge they face, upon which all of these other challenges are connected to, and strategies that they're implementing overlay over that. And so considering that, I think they've figured out how to meet the gap, as we've talked about in the presentation, in terms of non-conventional water supplies and improving water efficiency so that they can reduce their demand. But again, connected to that, the challenge isn't just simply a supply and demand issue, which is the point I wanted to make at the end, but all the sort of diversity of factors related there. What is causing their demand to increase, right? The influx of populations living there, from an attractive socioeconomic perspective, the robustness of the food industry, like in Saudi Arabia. And so the water scarcity still remains the important, most premier issue, but I'll still underline my last point that it shouldn't just be the focus, because all those other issues compound it further.
Thank you. And we have Abraham from our boardroom to ask another question.
Thank you for this presentation. I will not say water security is under pressure. I think it is also under threat, looking through what you have presented so far. So let's take Qatar as a case, because I know Qatar, the domestic water consumption per capita is high, though not as compared to Saudi Arabia, but it's high. And I also know that about over 60% of the groundwater is drawn for agriculture that feed or account for about 8% of agricultural water needs, like cultivating food, crops, and further. Now, what you have presented show that, like, yes, there's a political will, infrastructure, and they have the economic power to process seawater. But let's look at the outlook for water security. Are they doing anything about behavioral change so that water use behaviors at the household level, or maybe in terms of food crop cultivation, can be looked at so that water use efficiency can be improved?
That's a great point. It's that nuance may have been lost, or not may have been, is lost when we look at the sort of high scale of water use, and certainly when we dive down to, I'll call residential water use. And especially when you think of, I know you brought up Qatar, but some of this is also comparable to other countries that really have we'll call it a high tourism component. When you have tourism, and this is going into sort of the behavioral aspect of water use and how people value water and how they treat water. But when you have that high component of we'll call it temporary visitors that may not necessarily care enough about the water component, and frankly, it isn't presented as a scarcity issue, even though we all know it is that there is the potential of water loss or waste from the residential component, right? Overuse of water to support sort of the extravagance of the tourism industry, and some of these countries have a very sort of people view them in a luxurious manner, I'll just say, in this regard, to support the tourism industry and the influx of people that may want to live there. I think there are efforts, certainly when you look at the local water utility component, or water utilities, certainly in Qatar, certainly in the case of the UAE, the Abu Dhabi Environment Agency, etc., that are pushing to residents campaigns in terms of efficient water use, not keeping your water running when you're, doing your sort of brushing your teeth in the morning. All these things we've all grown up on in terms of reducing water loss in that regard. But it's also difficult to kind of control that when a significant amount of, call it population, even though it may be temporary, are visitors that are trying to tap into the sort of tourism side that is more luxurious. And so it is a concern that I think I'm glad you raised. One thing I'll say, not to minimize it, but one thing I'll say, when we think about water footprint, when it comes to residential water use, it is a much smaller water footprint than these other uses. Certainly agriculture, we've talked about, you raised the point, it's quite high, as well as industrial, certainly when you start to include the energy component. And so from a large scale water management perspective, I think it gets lost in the shuffle because of efficiency improvements there are important. I don't want to minimize the importance of pursuing them. But at that large scale, you're going to get more, you'll make more progress by increasing efficiency in energy, in the industrial side, and especially the agricultural side, which is why I think residential water conservation takes a back step, because the footprint there, the reduced footprint is much smaller.
Thank you.
But thank you for bringing that up.
Pick up from where you just stopped. In the era of water bankruptcy, everything you just described now just kind of fits directly into what we're talking about, living beyond your ideological means, and that's water bankruptcy. So I'll say every drop counts, so the water use efficiency at the municipal level that seems to be insignificant, when you take an area view, might eventually become very heavy, but because of the level of maybe money, the GDP and all that, it can easily be fixed, rather than, so it needs to be flagged, as a serious concern, enough to generate an attention for it to be fixed, especially in the context of tourism. I believe in behavioral architecture, so And they're already doing it at the large scale, especially in agriculture, all these soilless farming, reduced water infrastructure in reduced water use in agriculture, all those things. So similar behavioral architecture can be easily infused into the already stream of things. The control, I mean, if you enter into an hotel and you want to flush, there's a technology of, if you have calculated, the rate that you can't flush beyond this amount of this so much liter of water, different from the conventional, what's it called now? COR, that can easily be done. I've passed through Dubai and Abu Dhabi a number of times, because they're high end, so all those things can be done. But I guess they're missing that point now because, like you said, it's not a serious concern. So those of you, those research scientists in that context should really flag it as an issue. Like I said, every drop counts in this new era of global water bankruptcy. So I want to throw that here. My main question has to do with that brine settling at sea level. You said you were going to go back to read, but eventually I can't pick whether you actually went back to what the long-term implication of that will be, whether at the local scale and at the regional scale within the Gulf Peninsula, because it's a huge thing. When Qatar depends, 60% of their water use is on desalination, another country about 90%. So this is huge. So accumulation of brine over time at the seabed, it's not something we should just just close our eyes on. So I want your reaction on that.
Yeah. So let me, if I can, I'll address both points. And I absolutely don't want to give the impression of minimizing or saying any of these issues are insignificant. But I want to add a point to your first point on the residential side. In fact, I'll take it a step further, which was peppered in my discussion, which is this idea that scaling up of wastewater reuse, because that could also help bridge that sort of gap when you look at the residential water demand, right? So if you can keep, in a sense, recycling or reusing that footprint in a way through wastewater reuse, I think that can also help in terms of minimizing the consumption of that sector. And again, of course, improved efficiency is always important in terms of both behavioral as well as just water losses in the conveyance system in that regard, but then also add the wastewater use component. So I'll just add another line under your line, if you will, underline your first point. When it comes to the brine, again, not to minimize, but the point I wanted to make, it wasn't even the point. I was just reporting what the research studies we've looked at indicated, is that the increase in salinity because of brine are at points of discharge, which obviously makes sense. And the question then becomes, where do you see other higher concentrations? And that happens to be the accumulation at the salt bed. Not saying that's a good thing, but that's just what was reported or what was indicated. On the basin scale, though, just to repeat the earlier point, the overall average salinity in the Gulf hasn't really increased. It fluctuates within what is expected seasonally, just natural increases of salinity. But the larger question, which was a question not because I wanted to answer it, but really a question because I don't know myself, which is, even though it appears basin-wide, there is no large increases of salinity outside of those two areas. Could this be the case hundreds of years into the future, right? I don't know. And I'm just flagging it as something to pay attention. Not to say that because it's not an issue now, it won't be an issue that far into the future, for a couple of reasons. One, I anticipate that there will be more desalination plants on the Gulf. Just by virtue, right? If we're in this, as you said, water bankruptcy, we're in this water bankruptcy. You're trying to always, when you're bankrupt, you're always trying to catch up to get to the zero, to get to the balance of zero. So how are they going to do that outside of putting in more desal plants, right? It's not going to rain more. Your groundwater is going to be less. They're going to want to bridge the gap in supply. And the only way to do that, large scale, of course, outside of efficiency and all these other things we just talked about, is to increase the desalination capacity or the number of desalination plants. What does that look like in another 50 years?
Yeah.
We don't know. So just to make that point for you again.
We have another question from online, actually two. So the first one, who is the most vulnerable group to water scarcity in these GCC societies, women and children or elderly or migrants? And what are the measures taken in particular to protect them?
Yeah, there's a lot of vulnerable groups within the GCC. You know, when you start to fragment the different types of populations, not covered in the study, but I'll just reference it just to sort of answer this question. A couple of years ago, I did a deep analysis looking at Bahrain as an example of sort of the socio-economic political impacts related to climate and water. And in the case of Bahrain, I'm sure there you can draw similar parallels to other countries. Huge vulnerability, and this is mostly climate driven, but climate affects water, and so there's a loop there. Migrant workers are vulnerable. Certainly those that are working on water infrastructure at large. You know, this is a region that has extreme high temperatures. When we think about consequences of flooding because of this extreme weather that affects water infrastructure, but also access to water, poorer populations, even though, you know, the GCC for some people projects an image of wealth and prosperity, and for the most part that is true, there's still a very unfortunately significant amount of people that are living in poverty, which would surprise some people in some countries. Bahrain was one of those countries, again, in that study that I looked at, and there are old parts of cities in each of those countries that are under disrepair, right? They're older communities, older villages, older cities that don't have proper infrastructure, that don't have proper access to water. Smaller part of the population, certainly, but they exist. And I think that would surprise people to hear. So they are under threat, and certainly the elderly that are unable to you know, address these issues themselves due to age, disability, etc. And of course, women and children that may not have other family members to support them in that regard, living in, again, this combination of elderly, poor communities, and older communities, older areas. All of those are highly vulnerable to impacts of climate and impacts of water because of that.
Thank you, Dr. Mahmoud. So we actually went over time and we have to wrap it up right now. And sorry for missing Ima's question from online. We'll take a note and pass it along to the speakers to address afterwards. So thank you again, Dr. Mahmoud, for such an insightful and thought-provoking talk. And thank you all for joining us today. We look forward to seeing you at the next Science Talk, and have a wonderful day, everyone. Thank you.
Thank you. Appreciate it.